Start with a couple of adding and subtracting fractions to get you in that mindset for what we're about to do. So in our first example, our fractions do not have a common denominator. So what we need to do is remember multiply by that special form of 1, which is the opposite denominator in both cases. Remember, 5 over 5 is 1, 3 over 3 is 1. It doesn't change what you started with. Then we multiply straight across. And add your numerators. Remember, you do not add your denominators when you're adding fractions. In our second example, we have denominators with a common factor. So what I'm going to do is rewrite these so that I factor my denominators. So my first one, I've got 4 over 3 times 3. And my second one, I've got 10 over 2 times 3. So now they're written as prime factors. And then what I do is I multiply the other fraction by what's missing in the denominator. So when I look at my denominators, my first denominator is missing a 2. So I'm going to multiply it by 2 over 2. My second denominator is missing a 3. So I'm going to multiply it by 3 over 3. This is probably not the way you're used to seeing fractions being combined, but it'll make sense when we get into our rational expressions. So then we multiply everything out. In my numerator, I have 8. In my denominator, 3 times 3 is 9, times 2 is 18. My second fraction, I've got 30/18. And then I subtract my numerators and simplify. All right, this next slide is going to give you some steps for simplifying rational expressions, adding and subtracting, and they're the same steps for adding and subtracting fractions. It's helpful to change the subtraction to addition and distribute because adding is easier than subtracting. So that'll help you make fewer mistakes with your signs. Factor the denominators, similar to that second example that we just went through. Multiply by the special 1 like we did on both examples. And then distribute, combine like terms, simplify. All right, so let's take a look at some examples with common denominators, just to ease into this a little bit. So when you have a common denominator, you add your numerators, and you leave your denominator alone. And then you check to see if you can simplify. In this case, I have an x in the numerator and the denominator, so I'm going to cancel one of my x's. Also, I'm going to follow all directions and give the domain restrictions. So looking at my original denominators, I had 3x squared was my denominator, so that cannot equal 0. So when I divide by 3 and take the square root, my domain restriction is x cannot equal 0. Looking at my second example, I have subtraction. And because I have 2 terms in my second fraction, I am going to add the opposite so that I don't lose track of my negative sign. Now I'm going to combine like terms. So adding in my numerator, 9x minus 4x, I get 5x minus 12 all over x minus 4. My 5x minus 12 doesn't factor, so that's as simplified as it will get. And then my domain restrictions, my denominator was x minus 4, so that cannot equal 0. So x cannot equal 4. All right, so now we're going to take a look at denominators with a common factor. So what we want to do is factor all of our expressions. Anything that can factor, we want to factor. So I'm looking at my denominator, and my second denominator is the difference of squares. So I have x over x minus 2 plus negative 8 over x minus 2, x plus 2. Now similar to that second example with numbers that we saw, all I need to multiply my first fraction by is what's missing in the denominator. So what's missing is x plus 2. So I'm going to multiply my first by x plus 2 over x plus 2. Distributing in my numerator, I get x squared plus 2x over, and you can go ahead and distribute it back if you want to, the x squared minus 4 plus negative 8 over x squared minus 4. combine like terms. We've got the x squared plus 2x minus 8 all over x squared minus 4. And now that I think about this, I'm going to leave it unfactored. Sorry, I hope this doesn't confuse too many of you. Because what we want to do then is factor the numerator to see if there's anything that we can simplify. So this denominator right here is coming from my original factored denominator. Or you can think about factoring the x squared minus 4 again. So from now on, I will not be factoring, or not be multiplying back until the very last step. So in my numerator, what multiplies to negative 8 and adds to positive 2. And we have x plus 4, x minus 2. So that will cancel with one of my x minus 2's in the denominator. So my completely simplified answer is x plus 4 over x plus 2. Now when I'm giving the domain restriction, I have to look at my original denominators. So what I do is I look at where I first factored them to try and find my common denominator. And I had two different pieces in the denominator. I had an x minus 2, which cannot equal 0, and I had an x plus 2, which cannot equal 0. So x cannot equal positive or negative 2. All right, so let's take a look at another one similar to that. So I'm going to factor my denominators. I've got x minus 3 over what multiplies to negative 4 and adds to positive 3, and that would be positive 4 minus 1. And I'm going to distribute that negative. Even though there's one term, I'm still going to keep that thought process, distribute the negative through the second fraction, and I've just got my x plus 4. So now I take a look at what's missing. I've got an x plus 4 in both denominators, but I'm missing an x minus 1 in my second. So I'm going to multiply everything by x minus 1. Again, I'm going to leave my denominator factored in case something cancels later on. And I've got my x minus 3 over x plus 4, x minus 1. I'm going to distribute in the numerator on the second one, so I've got negative 2x squared plus 2x all over x plus 4, x minus 1. And then I'll combine like terms in the numerator. So I've got negative 2x squared plus 3x minus 3 all over x plus 4, x minus 1. So now I'm going to take a look at the numerator, and I'm going to factor out a negative 1. And I hope you guys don't mind if I kind of do this in the same step instead of rewriting it, because I want that coefficient of my x squared term to be positive when I think about factoring. So I'm going to pull out that negative 1, and that will change my 3x to a negative 3x and my 3 to a positive. Because my coefficient of my x squared is not 1, I have to use the AC method. So I'm thinking what multiplies to a positive 6 and adds to a negative 3. And I'm not getting that to factor, so I'm going to go ahead and multiply back out and then distribute in my denominator. And this will multiply back out to the denominator that I started with up here, because that's what I factored it to here. So I didn't think too hard about multiplying that back out. So look for those shortcuts when you're doing this. And finally, my domain restrictions. So I want to look at the first factoring step when I was trying to add my fractions for my domain restriction. And again, I had two unique terms in the denominator. I had an x plus 4, which cannot equal 0, and an x minus 1, which cannot equal 0. So x cannot equal a negative 4 or a positive 1. Next, we're going to take a look at the same questions. Never mind, we'll skip that one. The last one is where they have unlike denominators. So my first example, I've got everything completely factored. There's nothing I can simplify, and there are no common factors in the denominator. So I need to first of all, distribute my negative, and multiply this by the 3x minus 1 that's missing. Over in my first fraction, I'm missing a 2x plus 5. So I'm going to distribute in both of my fractions. In my first fraction, the 2x times 6x is 12x squared. 5 times 6x is 30x. And I'm going to leave my denominators in factored form just in case I can factor out my numerator later. Distributing my negative 4, I get a negative 12x squared plus 4x. And combining like terms in my numerator, my x squared terms cancel. 30x plus 4x is 34x. Let's add correctly. And since that's a single term, I can go ahead and distribute in the denominator and finish simplifying. So the 2x times 3x gives me a 6x squared. And then I keep track of the middle terms together. So I think about my 2x times negative 1 is negative 2x. And I keep track of that in my head as I add a 15x to it. So I get plus 13x. And finally, the 5 times negative 1 is negative 5. For the domain restrictions, again, I'm looking at these in factored form. And looking at my original denominators, I have that 3x minus 1 cannot equal 0. So when I add 1 and divide by 3, I get x cannot equal 1/3. And 2x plus 5 cannot equal 0. So subtracting 5 and dividing by 2, x cannot equal negative 5 halves. So those are my two domain restrictions. One final example. Again, it's in factored form. I don't have any common factors, so I'm going to go ahead and multiply my second one by 2x over 2x minus 5. And I'm going to multiply my first one by x plus 3 over x plus 3. All right, distributing my numerators, but keeping my denominators factored for now, I've got x squared. And again, keep track of that middle term in your head. 12x plus 3x is 15x. And 3 times 12 is 36. And in my second one, when I distribute, I get 6x squared minus 15x minus 4x is negative 19x plus 10, the negative 2 times negative 5, and leaving my denominator factored for now. Combining like terms in my numerator, I get 7x squared minus 4x plus 46 all over my denominator. So if this one factors, I'm going to have to check my AC method. So 7 times 46 gives me 322. So I'm multiplying, and then I would be adding to negative 4. So I'm going to try and find numbers that are pretty close together to see if they multiply to 322. May want to fast forward. I didn't have this one worked out ahead of time, so we'll see if I can come up with anything. And I'm not seeing any numbers that are going to work out for us. So I'm going to go ahead and distribute that denominator. X times 2x is 2x squared. And then keeping track of the middle terms, x times negative 5 plus 6x is a positive x, and 3 times negative 5 is negative 15. So there's our final answer. And the last piece before we finish is checking for any domain restrictions. So again, looking at these in factored form, x x plus 3 cannot equal 0, so x cannot equal negative 3. And 2x minus 5 cannot equal 0. So adding 5 and dividing by 2, x cannot equal 5 halves.